Tangent properties of circles. The tangent at any point of a circle and the radius through the point are perpendicular to each other. The tangent at any point on the circle and the radius through that point are perpendicular to each other. When you draw a perpendicular to a circle and the point of contact where the tangent is making with the circle, if you draw a radius from that point, then the radius and tangent are perpendicular to each other. If two circles touch each other, the point of contact lies on the straight line through the centers. When the two circles touching each other externally, the point of contact between the two circles lie on the line joining the two centers of a circle. When the two circles touch internally, the point of contact lies on a straight line joining the centers of the two circles. If two tangents are drawn to a circle from an exterior point, then the tangents are equal in length. The tangents subtend equal angles at the center. The tangents are equally inclined to the line joining the point and the center of the circle. If the two tangents are drawn from the point P to the circle, then the tangents are equal in length. Then PA is equal to PB because the tangents are drawn from the same point. Therefore, the lengths of the tangents are equal. The tangents subtend equal angles. This angle is equal to this angle at the center. These two tangents make equal angles at the center. The tangents are equally inclined to the line joining the center and the point. This angle is equal to this angle. That is, when two angles are drawn from the same point, the lengths of the tangents are equal. The angles making with the center of the two tangents are equal, and the angles made by these tangents with the line joining the center with the point are equal. A point A is 26 centimeters away from the center of the circle, and the length of the tangent drawn from A to the circle is 24 centimeters. Find the radius of the circle. This is the point A. The distance between the point and the center of the circle is 26 centimeters and the length of the tangent is 24 centimeters. We need to find out the radius of the circle. We know that tangent at any point and the radius through that point are perpendicular. This tangent and radius through that point are perpendicular. We know from the tangent properties of the circle. Therefore, we have a right angle triangle. By using the Pythagoras theorem, OA square is equal to AT square plus OT square. Therefore, OT, the radius, is equal to square root of OA square, the distance from the center to the point, minus the AT square, the length of the tangent square. They have given it as 26 and 24, square root of 26 square minus 24 square. We know that A square minus B square is equal to A plus B into A minus B. So we can expand and write. Instead of that, we are using the formula here. 26 plus 24 into 26 minus 24 26 plus 24 is 50. 26 minus 24 is 2. 52 is 100. The square root of 100 is 10 centimeters. That is, the radius of this circle is 10 centimeters. In the given figure, ABCD is a quadrilateral whose sides AB, BC, CD and DA touch the circle at points P, Q, R and S. Prove that AB plus CD is equal to AD plus BC, AD plus BC. Now let us say LHS in this, what we need to prove, AB plus CD, AB plus CD. AB can be written as AP plus BP. AB can be written as AP plus BP. And CD, the CD can be written as CR plus DR. This is equal to this plus this. Now we know from the tangent properties of a circle, the two tangents drawn from the same point, the lengths of these tangents are equal. Therefore, AP is equal to AS. AP is equal to AS. The tangents drawn from the same point, BP is equal to BQ. Therefore, BP is equal to BQ. BP is equal to BQ. The tangents drawn from the same point are equal, tangents to the circle. This is equal to this. CR is equal to CQ. Therefore, CR is equal to CQ. From the point D drawn, two tangents are equal. Therefore, DR is equal to DS. DR is equal to DS. Let us rearrange these things. AS plus DS, we are writing and putting the brackets and arranging these two together. BQ plus CQ. What is AS plus DS? That is AD. AS plus DS is AD. Then BQ plus CQ is BC. BQ plus CQ is BC. That is equal to RHS. Hence we have proved AB plus CD is equal to AD plus BC. We have used the tangent properties, the two tangents drawn from the same point to the circle. The lengths of those two tangents are equal. Before going into the next problem, let us recall what is rhombus. All sides have equal length. The rhombus will have all sides are equal in length. Opposite sides are parallel. It is a parallelogram having all sides are equal. Opposite sides are parallel. Opposite angles are equal. In a rhombus, all sides have equal length. Opposite sides are parallel. Opposite angles are equal. If all sides of a parallelogram touch a circle, show that the parallelogram is a rhombus. Let ABCD be a parallelogram touching the circles, the sides of a parallelogram touching the circle at P, Q, R and S. Because this ABCD is a parallelogram, the opposite sides are equal. That is, AB is equal to CD and BC is equal to AD. We need to prove, to make it as, show it as a rhombus, AB is equal to BC, that is equal to CD, that is equal to AD. Because for a rhombus, all sides have an equal length. Because it is a parallelogram, it's already, all the opposite sides are parallel. So we need to prove that all sides of this parallelogram are equal to prove this as a rhombus. That is, if all sides of a parallelogram touch a circle, it's going to be a rhombus. we are taking AB plus CD. AB can be written as AP plus BP. CD can be written as CR plus DR. Because the tangents to the circle are equal if they are drawn from the same point. Therefore, AP is equal to AS, BQ is equal to BP is equal to BQ, CR is equal to CQ, DR is equal to DS is equal to CQ, DR is equal to DS, DR is equal to DS. We are rearranging, then AP plus AD. AB is equal to CD. We know that these two are equals. AB is equal to CD. Therefore, 2 times AB is equal to CD, AD is equal to BC. So this means this is equal to this. We can write AB is equal to BC. Therefore, AB is equal to BC and CD is equal to AD. Hence, ABCD is a rhombus. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11. Fourth one. In the given figure, the incircle of triangle ABC touches the sides AB, BC and CQ at the points PQR. Show that AP plus BQ plus CR is equal to BP plus CQ plus AR, that is equal to half of perimeter of a circle. The lengths of two tangents drawn from the external point of a circle are equal. Let us take the LHS. LHS of the given AP plus BQ plus CR. AP is equal to AR, BQ is equal to BP, CR is equal to perimeter of a triangle. What is the perimeter? AB plus BC plus AC. AB can be written as AP plus BP. BC can be written as BQ plus CQ. This one AP BQ, AP BQ CR. We are rearranging AP plus but these two are equal. Here in the from 1, these two are equal. AR plus BP plus CQ. This can be written as 2 times AP plus BQ plus CR. That is AP plus BQ plus CR is equal to BP plus CQ plus CR. That is equal to half of, this is equal to half of the perimeter. AP plus BQ plus CR is equal to half of this perimeter. In the given figure, the incircle of triangle ABC touches the sides AB, BC and C at points PQ and R. Through that, show that AP plus BQ plus CR is equal to BQ plus CQ plus AR, that is equal to half of perimeter of a triangle ABC. We know that the lengths of two tangents drawn from the external point of a circle are equal. Therefore, this is the point. We have drawn two tangents. From this point, we have drawn two tangents to a circle. From this point, we have drawn two tangents to a circle. Therefore, this is equal to this is equal to this, and this is equal to this. Let us take, therefore, AP plus BQ plus here. AP plus BQ plus here. AP, because why we have taken AP plus BQ plus here means they asked us to prove AP plus BQ plus here. That's why we are taking this one. Therefore, AP plus BQ plus here. AP plus BQ plus here is equal to, what is AP? AP is equal to AR, because these two are two tangents drawn from the same point. This tangent is equal to this tangent. AP can be equal, we can be written as AP is equal to AR. We are writing AP is equal to AR. BQ is equal to BP, because we are drawing two tangents to the circle from the same point. Therefore, BQ is equal to BP. We are writing in place of BQ, BP. CR is equal to CQ, because two tangents drawn from the same point. CR is equal to CQ. CR is equal to CQ. AP plus BQ plus CR is equal to AR plus BP plus CQ. See, this first part we have proved. AP plus BQ plus CR. AP plus BQ plus CR is equal to BP plus CQ plus AR. This first part we have proved. We need to prove this other part of this is equal to half of the perimeter of a triangle ABC. Then let us take what is the perimeter of triangle ABC. Perimeter of triangle ABC is AB plus BC plus CA. AB plus BC plus CA. AB can be written as AP plus BP. AB is equal to AP plus BP. Then BC can be written as BQ plus CQ. BQ plus CQ. Then CA can be written as CR plus AR. CR plus AR. So we are rearranging the things. These are the things which are already there. We are rearranging. AP plus BQ plus CR we are taking and putting a bracket. Then BP plus CQ plus AR. BP plus CQ plus AR. We are just rearranging these things. We know that AP plus BQ plus CR and BP plus CQ plus CR, from this point, from 1, we know that these two are equal. So instead of writing two parts, we can write 2 times AP plus BQ plus CR. The perimeter of triangle ABC is equal to 2 times AP plus BQ plus CR. Therefore, AP plus BQ plus CR is equal to half of the perimeter of a triangle ABC. AP plus BQ plus CR is equal to BP plus CQ plus AR, which we proved from here. That is equal to half of the perimeter of the triangle ABC. In the given figure, a circle touches the side BC of triangle ABC at P. And this figure, given figure, the BC of triangle ABC touches the circle at P and also touches at Q AB produced, and also touches the circle at R AC produced. We need to prove AQ is equal to AR is equal to half of this perimeter of this triangle. The triangle touching at the circle at P and the AB produced at Q, AC produced at R. We need to prove AQ is equal to AR is equal to half of the perimeter of this triangle ABC. Let us take the perimeter of the circle ABC. What is the perimeter of the circle ABC? AB plus BC plus AC. AB we are keeping like that. AC we are keeping like that only. Now we will see. BC can be written as BP plus CP. We are keeping in this triangle, we are taking the perimeter of this triangle. We are keeping AB as it is, AC as it is. we cannot do anything with this. We are only taking, because this can be split into two parts, BP plus CP. AB we are keeping like that. BC we are keeping, splitting and keeping. We can split this BC. BP plus CP we are keeping AC as it is. Then AB plus BQ. BP plus CP. See this BP, because BP and BQ are the two tangents from the same point B. We know that the tangents drawn from a point, two tangents drawn from a point to the circle from the same point, the lengths of those two tangents are equal. Therefore, BP is equal to BQ. BP is equal to BQ. Here, same it is. From point C, two tangents are drawn here to the circle. Therefore, this tangent is equal to this tangent. Tangents drawn from the same point to a circle are equal. CP is equal to CR. We are writing in place of BP, BQ. In place of CP, we are writing CR. In place of BP, we are writing BQ. In place of CP, we are writing CR. Then we are clubbing these two. AB plus BQ, CR plus AC. AB plus BQ and AC plus CR. What is AB plus AQ? AB plus BQ is AQ. AC plus CR is AR. AB plus BQ is equal to AQ. CR plus AC is AR. AQ is equal to AR. Why? AQ is equal to AR. Because these are the two tangents drawn from the same point A. AQ is equal to AR. So that we can write AQ plus AR can be written as 2AQ or 2 times AR. Therefore, AQ is equal to half of a perimeter of a circle, or AR is equal to half of a, that is AQ is equal to AR is equal to half of a perimeter of a triangle ABC. We are using the tangent properties of a circle here in three places. Here B, from point B we are considering these two as two tangents of a circle. From point C we are considering these two tangents from the same point C. From A we are considering these two. So there are 3 points we are using the tangent properties, and we are just substituting the values here. Where we needed to prove AQ is equal to AR is equal to half of a perimeter of a triangle. Then first we took a perimeter of a triangle ABC. That was easy, so that AB plus BC plus CA. Then we kept these two as it is because we cannot do anything with these two things. BC we split it into BP plus CA. We know that this is equal to this, this is equal to this. We replace it, this is equal to this, this is equal to this. Then this plus this has become AQ. This plus this has become AR. We also know that this is equal to this. Then hence we have proved the thing. In the given figure, O is the center of the circle. AB is the tangent. AB is the tangent. If AB is 15 centimeters, AC is 7.5 centimeters, we need to calculate the radius of this circle. We know that any tangent to a circle, from that point, the radius which we are going to draw, that is perpendicular to the tangent drawn. Therefore, if we are drawn the radius from here to here, that is equal to the radius. Therefore, this radius and this tangent are perpendicular to each other. Therefore, we get a rectangle triangle here. So, by using the Pythagoras theorem, we can find out the radius. So, we know that AC is 7.5. Therefore, OA is equal to R plus 7.5. So, we can find out OA square is equal to AB square plus OB square. What is OA? OA is R plus 7.5, R plus 7.5 whole square, plus AB they given it as 15 square, plus OB is R square. So let us expand this. R square plus a plus b whole square, a square plus b square plus 2ab, r square plus 15r plus 7.5 square is equal to 56.25, that is equal to 15 square is 225, r square, this r square got cancelled, therefore 15r is equal to 225 minus 56.25, that is equal to 168.75. Therefore r is equal to this divided by 15, that we got it as 11.25 centimeters. The radius of this circle is 11.25 centimeters. So we use the property of a tangent property of a circle, that so the tangent touching a circle from the radius from that point are perpendicular to each other. In the given figure, O is the center of a circle. The tangents at A and B meet at C. O is the center of a circle. The tangents from A and B meet at C. If the angle ACO is 30 degrees, we need to find out what is the angle, this one, BCO. We need to find out BCO, and AOB. We need to find out this angle and this angle. They are given just two tangents and one angle. We need to find out this angle and this angle and this angle. We know that tangents drawn from the same point are equal. Therefore, this is equal to this. This is equal to this side. If we consider this as a whole triangle, this is one triangle and this is one more triangle. Therefore, this side of a triangle is equal to this side of a triangle. And because this and this are radius of a circle, this side is equal to this side. In these two triangles, ACO and BCO, these two triangles, we know that tangents drawn from the same point to the circle are equal. This side is equal to this side, because this is the radius, this side is equal to this side, because this is a common OC. Therefore, the triangle, this triangle is congruent to this triangle. Once these two triangles are equal, therefore from simplicity, this angle is equal to this angle. We found out the one part of the question. We found out BCO is equal to 30 degrees. Once again I am repeating, if we consider these two as triangles, this side is equal to this side, this angle is equal to this side is equal to this side, and this is a common, then we can easily say that this triangle is congruent to this triangle. Therefore, this angle is equal to this angle. We got this angle as 30 degree, which they asked us to find out. Now we have to see in this, if we consider this in this one triangle, we know this is 90 degrees. The angle, because radius and tangent drawn from that point are perpendicular, therefore this is 90 degrees. This is 30 degrees. Just now we found out. We know that the sum of the interior angles of a triangle is 180 degree. Therefore, 180 minus this will give this. 180 minus 90 minus 30 will give this angle. That is AOB. This is 60. Therefore, AOB is equal to this plus this. We know these two triangles are congruent. Therefore, this angle is equal to this angle. We found out this as 60 degree. 60 plus 60 is 120. We have found out the second part of this question. We found out this as 30 degrees and this as 60 plus this is 120 degrees. Then we have to find out the third part of this question. This is, we know that the angle made by an arc, at a point of the circle, any point on the circle, is half of this angle made at the center of the circle. An arc made on the point of a circle is equal to half of the angle made at the center of the circle. Just now we found out the angle here as 120. This is an arc. This is 120. Therefore, this angle is equal to half of this, that is 60 degree. We found out all the three parts. This is 30 degrees, this is 120 degrees, this is 60 degrees. The angle made by an arc at a point on the circle is half of the angle made by an arc at the center. This was the original picture what they are given. We changed into this type so that it can be easily found out. First we made these two triangles are congruent. Once these two are congruent, this angle is equal to this angle. So once these two triangles are congruent, then we found out, because in interior angles of a triangle 180, once we know the two angles, we can easily find out the third angle. By that way we found out this. So because these two triangles are congruent, this angle is equal to this angle. So we found out easily this part, this plus this is 120. We also know that the angle made by an arc and the point of a circle is equal to half of the angle made at the circle. We know that 120 divided by 2 will give this. In the given figure, PQ is equal to QR, and PC and CQ are tangents. PC and QC are tangents to the circle with a center O. We need to calculate the values of the angle QOP and QCP. They have given this figure. In this they say that PQ is equal to QR and PC and QC are tangents. We need to find out this angle and this angle. They have given this angle as 68 degrees. Nothing else they have given. They have given only these two are equal, these two are tangents, and this angle is 68 degrees. We need to find out this angle and this angle. I am rewriting the picture what they are given. So this, they are telling this side is equal to this side, and this is 60 degrees. We know this. So when two sides of a triangle PQ, or when two sides of a triangle are equal, we call it as isosceles triangle. In this isosceles triangle, the angle opposite to the equal sides are equal, because this side is equal to this side of a triangle. Therefore, opposite to this is this angle is equal to opposite this angle. These two are equal. Opposite angles of equal sides are equal. Because these two sides of a triangle are equal, they are given in the picture, in the figure. This angle is equal to this angle. Opposite to the equal sides are equal. This is equal to this. We know that the sum of the interior angles of a triangle is equal to 180 degrees. 180 minus this divided by 2 will give this, because these two are equal. 180 minus 68 divided by 2. Why divided by 2? These two are equal. So when we add these two, we will get the same number here. Therefore, divided by 2. Therefore, 180 minus 68 will give 122. Divided by 2 will give, because these two are 56. These two are equal. So 180 minus this angle will give the sum of these two. When we divide that by 2, will give the value of this. That has become 56 degrees. This is 56 degrees. By using the isosceles triangle, we found out the value of this angle. Which is this angle? This is the angle made by this arc. This is the angle made by this arc of a circle. We know that angle made by an arc on the center, angle made by the arc on the circle is double the angle made by it at a point on the remaining part of the circle. This angle is equal to 2 times double the angle made by the arc on the part of the circle. See here, this angle made by this arc at the center is double the angle made on the point of the circle. Just now we found out this is 56 degree, therefore this angle is equal to 2 times 56, that will become 112. So they asked us to find out this angle, we found out this as 112. What we did, because these two sides of a triangle are equal, therefore opposite angle equal. Once we know this, these two are same, 180 minus 68 will give 112. 112 divided by 2, that will give the 56 of this. We know that the angle made by an arc on the center is double the angle made by it at a point on the remaining part of the circle. Therefore, this is equal to 2 times this. 2 times, that is 56 into 2, that has given 112. So one part is over. We need to find out this. We know that the angle made by an arc on the center is double the angle made by it at a point on the remaining part of the circle. Therefore, QOP is equal to 2 times angle QRP, that is equal to 2 into 56, that is equal to 112. We know that the tangent on the radius from that point are perpendicular. Therefore, this angle is 90 degrees and this angle is also 90 degrees, and this angle we just now find out as 112 degrees. What is this? This is a quadrilateral. OPCQO, this is a quadrilateral. Once we know 1 plus 1 plus 3 angles of a quadrilateral, we can easily find out this, because the sum of the interior angles of a quadrilateral is 360 degrees. We know that this is 90 degrees, this is 90 degrees, this is 112 degrees, just now we found out. Therefore, this is equal to 360 minus 90 minus 90 minus 112, that will give this as 68 degrees. So they asked us to find out this angle and this angle. We found out very easily. How we did it? We took this triangle, isosceles triangle, because these two are equal, therefore the opposite angles are equal. Then 180 minus this will give the sum of these. When you divide this with 2, will get the angle of this. And we know that from the properties of an arc, the angle made by an arc at the center is double the angle made by on the remaining part of the circle. Therefore, this is equal to twice this. We know that this is 56 into twice will given this. And we know that the interior angles of a quadrilateral is 360. This is 90 and this is 90. This is 112. Therefore, 360 minus 90 minus 90, 112 will give this. Sum of the angles of a quadrilateral is 360 degrees. 90 plus 90 plus 112 plus this angle QCP is equal to 360 degrees. Therefore, QCP is equal to 360 minus 292. 90 plus 90 plus 112 is 292. That will give 68 degrees. In this part, this is the important point we need to remember. The angle made by an arc on the center of is double the angle made by it at a point on the remaining part of the circle. And angles opposite to the equal sides of isosceles triangle equal, and the tangent and the radius drawn from the point of contact is perpendicular, these two, and sum of the angles of a quadrilateral is equal to 360 degrees. These are very interesting problems. In the given figure, O is the center of the circle and AB is a tangent to it at a point B. Find BAO. We need to find out BAO. AB is a tangent and they were given this as 65 degrees. We need to find out this. When you look at this picture, what is this we are finding it? There are so many triangles here. There is one triangle here first. So we need to look into this because we have two, nothing is there here except for the circle and one tangent, and this, because this is a tangent, we know that a tangent drawn to a circle and that radius is equal to 90 degrees, that they have given already. This is 65 degrees they are given. If you consider this BCD as a triangle, we know that the sum of the angles of interior, sum of the angles of triangle is equal to 180 degree. Once you know this as 65 and this is 90, we can easily find out this. So that will be 180 minus 65 minus 90, that will give as 25 degrees. This is 25. See, we are taking this triangle, and that we know, once you know the two angles of a triangle, the third will be easily found out. That is 180 minus 65 minus 90, that is 25. This is 25. So what can we see? One more triangle here. This is a small triangle here. In this, because this is a radius and this is a radius, the two sides of the triangle are equal. So once these two triangles are equal, the opposite angles, opposite angle is this, opposite angle is this. These two angles are equal. Opposite angles of equal sides are equal, because this is a radius, this is a radius. These two are equal. Once these two are equal, the opposite angles of these two sides are equal. This is equal to this. Just now we found out this, in this triangle this is 25. Therefore this is equal to this. This is 25. If this is 25, see, the vertically opposite angles are equal. This angle is equal to this angle. We are coming to the here. We need to come to here. Nothing is here. What we did, we found out this. Then we found out this, because these two are equal. Once these two are equal, opposite angles are equal. Then this is equal to this, because it vertically opposite angle. Once you know this and once you know this, only one. If you consider AD is a triangle, we need to find out this. For that, we already know this as 25 degrees. What else? We need one more angle. In a triangle, we need to know two angles to find out the third angle. We only know this angle because this is equal to this. But here there is 65. Whole angle is 180. 180 minus 65 will give this angle. Therefore, this angle, we know this angle and this angle, we can easily find out this. 180 minus 65 is 115. 115 plus 25 minus 180 will give this. Very easy. See, just we'll recap it. They have given this circle, they say this is a tangent, they have given this. Because this is a tangent, this angle is 90 degrees. This plus this, 180 minus this plus this will give this angle. In this triangle, these two sides are equal because this is the radius of a circle. Once these two are equal, opposite angles are equal. If this angle is equal to this angle, we found out this as 25 degrees. This is 25. Therefore, these two are equal because it is vertically opposite angles. We need one more angle to find out this. So we know that in the straight line, the angle on the straight line is 180 degrees. 180 minus 65 will give this. Therefore, if we consider AD is a triangle, 180 minus this will give A. Then keep writing. Later on you can write everything whatever you want. First you understand the problem properly. What we did, we took this triangle, then we took this triangle, then we took this straight line, we found out this, then we took this triangle. Then keep on writing. You need to understand the problem first, then start writing. I am rewriting the picture, the figure, just go through it. Nothing. See, it looks complicated and you immediately look at it. You just see, this is one triangle. This angle, how did we find out this angle C? In triangle BDC, angle C is equal to 180 minus 65 minus 90, that is equal to 25. So we have found out this let us go one by one. We took this triangle, then we found out this. We know this is equal to this because they two are radius. We are taking this triangle, the opposite angles are equal. So opposite angles are equal. Once we know that this is equal to this, so these two are vertically opposite angles. This is equal to this. So we know one angle. So we need to find out this. So this is going to be 180 minus 65, 115. Once we know these two angles in a triangle ADE, 180 minus 115 minus 25 will give 40 degrees. Very, very easy. We need to put little mind into it. In the given figure, in triangle PQR, it is given that PQ is equal to 24 centimeters, QR is equal to 7 centimeters, and PQR is equal to 90 degrees. Find the radius of the inscribed circle. This is the question. They have not given any figure. We need to write a figure. In triangle PQR, it is given that PQ is equal to 27 centimeters, QR is equal to 7 centimeters, and PQR is equal to 90 degrees. Find the radius of the inscribed circle. The circle is inscribed inside the triangle PQR. They given this one side PQ as 24 centimeters, at angle PQR as 90 degrees, and QR as 7 centimeters. We need to find out the radius. So when this is right angle triangle, we can easily find out the other side of a triangle by using a Pythagoras theorem. Therefore, PR is equal to square root of 24 square plus 7 square, that is 625, that is equal to 25. By using a Pythagoras theorem, we found out this. So I am rewriting the picture here to make you understand better and easy. We know that the tangent drawn from the point to a circle are equal. Because this inscribed, the circle touches all the sides of a triangle from point P. On one point vertices of a triangle, these two are tangents to the circle. Therefore, this tangent is equal to this tangent. If you take Q as a single point and these two are tangents to the circle, therefore this is equal to this. And from point R, this side is equal to this side because these are the two tangents drawn to the circle. So we also know that, see, this tangent drawn from the circle and the radius at that point is equal to these two are perpendicular, these two are perpendicular. Therefore, this is 90 degrees, this is 90 degrees, this is they have given it as 90 degrees. When the three angles of a quadrilateral is 90 degrees and the sides are equal, see, this is equal to this, so then this is a square. This is a square. When the adjacent sides of a quadrilateral are equal and the angles are 90 degrees, then that is a square. Therefore, AQ BO is a square. This is a square. Therefore, we know that from here to here is 24 centimeters they have given. We can easily find out this length. Therefore, PA is equal to 24 minus R. See, we found out this because we know this as 24. 24 minus R will give this. Why you are finding out? We want this. So this, because these two tangents are equal, then PA is equal to PC. This will become 24 minus R. Here, this they were given it as 7 centimeters. Therefore, this part is equal to 7 centimeters minus this. This is 7 minus R. We found out this one because these two are equal, that is going to be 24 minus R. this is equal to BR is equal to 7 minus R. We know that for tangent properties, this tangent is equal to this tangent. Therefore, 7 minus R. PR is equal to 7 minus R plus 24 minus R. Why we are using all these things? Because we need to find out R. We already know that PR is equal to 25. We found out. By using this, we are finding out this 24 minus R and 7 minus R. We have only one variable here. This plus this is equal to 25. Therefore, PR is equal to 24 minus R plus 7 minus R. Substitute the value for PR, which is 25. Then we can easily find out R is equal to 3 centimeters. See, they have given it as triangle PQR. PQ is equal to 24 centimeters, QR is equal to 7 centimeters, and PQR is equal to 90 degree. We need to find out the radius of the inscribed circle. So for that, what we did, we found out the third side of the triangle, and we proved OAQB is a square by using the tangent properties. By using the tangent properties, we proved that ABOQ is a square. Once we prove this square, then these two will become equal to R. Once we know these two are R we can shift to this part by using the tangent properties once again. Once we know that this plus this is equal to 25, it will become very easy for us to find out the radius of the R. So we need to go very slowly. Whenever you need to understand the problem first, then it will become everything easy. PR is equal to 24 minus R plus 7 minus R. 25 is equal to 24 plus 7 minus 2R. Therefore, R is equal to 3 centimeters. Before we go to the next problem, let us see some of the properties of a circle. The angle in a semicircle is a right angle. The angle in a semicircle is a right angle. Let us consider this semicircle of this whole circle. We are taking the semicircle. This is the diameter passing through the center. Any angle on the semicircle is right angle. Any angle. See, this angle made by here, it is 90 degrees. Even if we draw like this, it's going to be as many angles you make, that's going to be 90 degrees only. Any angle, the angle in a semicircle is a right angle. The angles in this semicircle is going to be 90 degrees. Like this, if we do, this is going to be 90 degrees. If you draw like this, it's going to be 90 degrees. If you draw like this, it's going to be 90 degrees. The angle in a semicircle is a right angle. Why we are going through this means we need to use this property in the future problem. The angles in the same segment of a circle are equal. This is the segment of a circle. This is the segment of the circle. The angles made in the same circle. This is my angle made by this segment. This is also angle made by this segment. Therefore, these two are equal. Angles in the same segment of a circle are equal. Angles in the same segment are equal. In the given figure, xy is a diameter of the circle. xy is the diameter of the circle. This is the diameter. xy is the diameter of the circle. PQ is a tangent at the point on the circle at y. If AXB is equal to 50 degrees and ABX is 70 degrees, calculate BAY. Calculate BAY and CPY. They are given this as the diameter, xy as a diameter, PQ as a tangent at the point of a circle y, and they are also given that AXB is 50 degrees and ABX as 70 degrees. They are asking us to find out BCY and BAY. They are asking us to find out BAY and CPY. They are asking us to find out two angles in the given figure. This problem is very interesting. Let us go by step. I have written different pictures to make you understand better and easily. In the given figure, we know these two angles are given by the problem, 50 plus 70. We have this triangle. This is a triangle. Once we know the two angles of a triangle, the third angle can be easily found out. 180 minus 70 minus 50 will give 60 degrees. And this triangle, these two they were given, we found out this as 60 degrees. 180 minus 70 minus 50. We have found out this angle. Then we'll go to the next picture. We know that the angle in a semicircle is a right angle. Any angle inside the semicircle is a right angle. So let us consider this as a semicircle from this point. Therefore, this angle is going to be 90 degree. We know that angle in a semicircle is a right angle. If we consider this semicircle, this angle is going to be 90 degrees. This is going to be 90. We have found out just now this has 60 degrees. This is 90. Therefore, this angle, see this angle made in the semicircle is 90 degrees. 90 minus 60 will give this angle. 90 minus 60 will give 30 degrees. This part, this small angle here is 30 degrees, because we know that any angle in a semicircle is 90 degrees. This is 90 degrees. 90 minus 60 will give 30 degrees. This is 30 degrees. And we also know that angles in the same segment of a circle are equal. This is the segment. We are taking a segment of a circle. The angles made by that segment are equal. Which are the angles made by the segment? One angle here and one angle there. This angle is equal to this angle. We just now found out this as a 30 degrees. Therefore, this is 30 degrees. See, from the previous picture, we found out this angle is equal to 60 degrees because this was 50. 50 plus 70, we deducted from 180, we got it 60. We know that angle in a semicircle is a right angle. This is if you take this as a semicircle, this angle is 90. This angle is 90. 90 minus 60 will give this angle. We also know that angles in the same segment, this is a segment, this angle is equal to this angle. We found out this as 30 degrees, therefore this is equal to 30. Now let us come to this triangle. Once we, in any triangles, if you know two angles, third angle can be easily found out. That is 180 minus 70 minus 30 is 80. This is 80 degrees. See, from the previous picture we found out this angle. In this we found out this is 30 degrees. Once this is 30 degrees, we know that because of a same segment angles are equal, then this is equal to this. Once you know these two, we can find out this as 80 degrees. 180 minus 70 minus 30 will give 80 degrees. Next we'll go to the next picture. Just now we found out this angle as 80 degree. We know that vertically opposite angles are equal. If this is 80, this is going to be 80. This is 80. And we also know that this is a 90 degrees because the tangent and the diameter makes perpendicular to each other. Therefore, this is 90 degree. This is 90 degree. This is 80. Once we consider this as a triangle from here to here, 90 plus this with, when you minus with 180 degree, 180 minus 90 minus 80 will give this angle. 180 minus 90 minus 80 will give 10 degree. This is 10 degree. This is what we needed to find out, this angle. So I will show all the pictures together. It's very easy. We have to go step by step. We found out what we found out. We found out first this angle, then we found out this angle. Because these two are equal, this has become 30 degrees. Once we know these two, because they were given this is 70 degrees, this is we could able to find out this as easy. Once you find out this, these two are vertically opposite angles, and this is 90 degree by the property of a tangent 90, then 180 minus this plus this will give this 10 degrees. I'll recall once again. First what we did, we found out this angle because we were knowing this and this, and we found out this small angle because angle in a semicircle is right angle. This was 90 degrees and we found out this is 60, 90 minus 60 will give 30. We also know that the angles of the in the same segment of circle are equal. This was 30, therefore these two are equal, this has become 30. This was 30 and this was 70, then we could able to easily find out this is 80 degrees. Vertically opposite angle equal, this is 80, this is 90, then we can easily found out this 180 minus 90 minus 80 will give 10 degrees. These problems are very interesting. Go slowly, understand yourself, that it will become very easy for you. Ask us to find out these two. We found out this has 30 degrees and this has 10 degrees. How we went through that? We found out first this triangle has 60 degrees and this has 90 minus 60 it gave. How did we get 90? We know that the angle in a semicircle is a right angle, therefore 90 minus 60 we got this. So it has this is 30. How did we get this 30? Because angles in the same segment are equal. These are the two angles which are there in the same segment, therefore this is equal to this. So once we found out this, so this is vertically opposite angles and this is 90 degree because it is a tangent to the diameter. Once we know these two, it is very easy to find out this. You can easily, once you understand the problems, rest will become easy. So if you don't understand, everything will look very difficult. ABC is a triangle with AB is equal to 10 centimeters, BC is equal to 8 centimeters, AC is equal to 6 centimeters. Three circles are drawn touching each other with vertices as their centers. Find the radii of three circles. ABC is a triangle. AB is equal to 10 centimeters, BC is equal to 8 centimeters, and AC is 6 centimeters. Three triangles are drawn with vertices as their centers. This is the vertices, these are A, B, C are the vertices of the triangle. With keeping A as a center, we have drawn one circle. B as a center we have drawn one circle, and C as a circle drawn another circle. So they are touching each other. We need to find out the radius of the three circles. Let us take radius of the circle as x and radius of the circle as y and radius of the circle C as z. They were given AB is equal to 10 centimeters, AB is 10 centimeters, that is equal to x plus y. This is the radius of A, this is the radius of the circle B. This is x plus y is equal to 10 centimeters. Then BC is equal to y plus z. Therefore BC they were given it as 8 centimeters, that will be y plus z. AC they were given it as 6 centimeters, but AC is equal to x plus z because this is a diameter of A, this is a diameter of radius, this is the radius of circle A, this is the radius of the circle C. So let us add these 10 plus 8 plus 6, we get 24, x plus x, y plus y, z plus z. 2x plus 2y plus 2z, 2 we have taken it as common, 2x plus y plus z. 24 divided by 2 is equal to x plus y plus z is equal to 12. So we know that x plus y plus z is equal to 12, and we also know that x plus y is equal to 10. Therefore, or y plus z is equal to 8. So x plus y plus z, we need, when you want to find out x, we can replace this y plus z is equal to 8 centimeter, that will give 12. Therefore, x is equal to 12 minus 8, that will be 4 centimeters. So by using this, you can find out, substitute here 4 centimeter, you will get the y, substitute y, you will get z. X is equal to 4 centimeters, y is equal to 6 centimeters, z is equal to 2 centimeters. In the given figure, all sides of a quadrilateral ABCD touch the circle with center O. We need to prove AOB plus COD. AOB plus COD is equal to 180 degrees and BOC plus AOD is equal to 180 degrees. This is a quadrilateral touching the circle at 4 points, and we need to find out this angle plus this angle is equal to 180 degree, this angle plus this angle is equal to 180 degrees. We'll rewrite the picture like this. Originally they have given it as ABCD as a quadrilateral. Like this, they asked you to find out this plus this is equal to 180 degree, this plus this is equal to 180 degree. So we are just joining the tangent point with the center, joining the tangent at the circle with the center. This PQRS are the tangent at the circle. So this and this we are joining. We know that the tangents, we know that if the tangents drawn from the same point to the circle, the sides are equal, these two angles are equal, the angles subtended on this are equal. Two tangents from the drawn from an external point subtend equal angles at the center. We know that if we are drawn two tangents from this point to the circle, these two tangents are equal. These angles, the angle made by the tangents with this line are equal, and angles at the center are equal, subtended or equal. Therefore, this angle is equal to this angle. Angle 1 is equal to angle 2. Angle 1 is equal to angle 2. Similarly, these are the tangents with B. These two are the tangents from point C, and these two are tangents from this. Therefore, angle subtended by the tangents at the center, these two are equal. Angle 3 is equal to 4, angle 5 is equal to 6, angle 7 is equal to 8, angle 1 is equal to 2, angle 3 is equal to 4, angle 5 is equal to 6, angle 7 is equal to 7. This is the tangent property. Two tangents drawn from an external point subtend equal angles at the center. And we also know that sum of all angles around a point is 360 degrees. This is a point. Sum of all the angles around the point is 360 degrees. This plus 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 this is 360 degrees. This angle, 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 all sum of all those angles is equal to 360 degrees. So let us see. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 is equal to 360. We know that angle 1 is equal to 2, angle 3 is equal to 4, angle 5 is equal to 6, angle 7 is equal to 8 is equal to, so that 1, in place of 1 we can say 1 because 2 we can say 1 because 1 and 2 are equal. Angle 1 is equal to 2, angle 3 is equal to 4, 4 plus 4, 5 plus 5, 8 plus 8 is equal to 360 degrees. Because there are 2 here, we can take out 2. 2 into 1 plus 4 plus 5 plus 8. 1 plus 4 plus 5 plus 8 is equal to 360 degrees, or 360 divided by 2 is equal to 180 degree. 1 plus 4 plus 5 plus 8. 1 plus 4. 1 plus 8. 1 plus 8 is AOD. 4 plus 5. 4 plus 5 is BOC is equal to 180 degree. Why we have taken in place of, instead of taking 3, we have taken 4. We wanted, see, we need to prove that AOB is equal to COD plus AOB plus COD is equal to 180 degree. BOC plus AOD is equal to 180 degrees. So we have taken this plus this plus this, so that we can prove that these two are equal to 180 degree. Here we have taken 4 and we have taken 5 and 8 to make it these two, sum of these two is equal to 180 degree. Similarly, we can take in the other part this and this is equal to this plus this is equal to 180. We have taken similarly 2 times 2 plus 3 plus 6 plus 7 is equal to 360, or 2 plus angle 3 angle 2 angle 3 angle 6 angle 7 is equal to 180 degree. Angle 2 plus 3, that is AOB, 2 plus 3 is AOB, 7 plus 6 is COD, is equal to 180 degrees. Two circles of radii 25 centimeters and 9 centimeters touch each other externally. Find the length of direct common tangent. There are two circles here. The radius of one circle is 25 centimeters. The radius of the other circle is 9 centimeters. We need to find out the length of the common tangent, that is PQ is equal to what? Draw BL perpendicular to AP. So these are the two circles touching each other. We have drawn common tangent. So draw BL perpendicular to this. Once you draw perpendicular, this is going to be rectangle. This is BQ. They have given it as 9 centimeters, and drawing directly from here to here perpendicular. That is 90 degrees. Therefore, this side is equal to this side and this side is equal to this side. So we can find out this part, because the radius of this bigger triangle is 25, and because we have drawn from this point as perpendicular, this side is equal to this side. Therefore, BQ is equal to PL. Therefore, this part will become 25 minus 9. 25 minus 9 will give 16 centimeters. This part is 16 centimeters. And we also know that this plus this is 25 plus 9. The length AB is equal to 25 plus 9. So this is a right angle triangle, because this line BL is perpendicular to AP. This is a right angle triangle. So once we know this, we can find out BL by using a right angle triangle. Thus this we just now found out as 16 centimeters. 25 minus 9 will give this. 25 plus 9 will give the AB. We can easily find out BL. AB is equal to 25 plus 9, that is equal to 34 centimeters. By using the Pythagoras theorem, AB square is equal to BL square plus AL square plus BL square. This is AB is 34 plus 16 square plus BL square. Therefore, BL square is equal to 34 square minus 16 square. Instead of expanding this, let us use the A square minus B square formula. BL square is equal to A plus B into A minus B. 34 plus 16 is 50. 34 minus 16 is 18. Because it will become very easy instead of expanding and doing this. A plus B into A minus B. So 18 5s are 90. This is 0. We are keeping 900. Therefore, BL is equal to square root of 900. PQ is equal to BL is equal to 30 centimeters. We know that this is a rectangle. Once we find out this BL, that is going to be PQ. That is what they ask us to find out. The common tangent we need to find out PQ. So once we found out BL, that will be equal to PQ. Therefore, PQ is equal to BL is equal to 30 centimeters.